Right now, there is a single rock floating through space worth $27 quintillion, enough to make every person on Earth a billionaire several times over. Despite billions in investment and decades of hype, not a single mining operation has succeeded. Why are we still stuck on Earth when infinite wealth floats just above our heads? The answer will shake everything you believe about humanity's space future. Because it turns out, reaching for space riches might be building our own extinction event. So what's stopping us from grabbing this cosmic treasure? The answer starts with a problem no Earth miner has ever faced. Gravity doesn't exist. Every mining technique we've perfected over centuries relies on one simple fact: heavy stuff falls down. Drill, blast, collect. But in space, valuable metals don't separate from waste rock. They just float away into the void. Engineers are desperately trying alternatives, but most of these technologies are stuck at technology readiness level 4. Laboratory testing, not space ready. The lab tests reveal another zero-gravity horror. Mining creates dust, and without gravity to settle it, you get clouds of glass-sharp particles floating at orbital speeds, destroying everything they touch. This dust problem makes everything exponentially harder. Mining probes must travel millions of kilometers and operate for years making split-second decisions alone, while their solar panels weaken. Their batteries degrade from extreme temperatures, and space dust destroys their sensors. One critical failure could turn a multi-billion-dollar mission into expensive space junk. But cracking the technology only reveals the next obstacle: logistics. Asteroid mining isn't just one operation. It is an entire supply chain floating in the void. We need spacecraft design and manufacturing systems, mining equipment, processing facilities, and return transportation systems all working together across millions of kilometers. Each component must function flawlessly without maintenance for years. But once we mine something, where do we put it? Take water, for example, a potential fuel source that needs special tanks in zero gravity to stop it sublimating into space. Metals can't just be piled up. We have to anchor, seal, and shield every gram. Otherwise, radiation, temperature swings, and drifting debris could ruin the payload before it ever heads home. One failure in this chain dooms everything. Moving between asteroids requires burning fuel to change velocity and direction. The more you maneuver, the more extracted material you waste as propellant. You end up expending tons of precious metals just to reach the next mining site, like running a delivery service that burns more cargo than it delivers. Even if we somehow master the technology and logistics, we hit the ultimate dream killer: the economics. Every kilogram of mining equipment costs $1 million just to escape Earth's gravity. NASA's OSIRIS-REx mission burned through $1.1 billion to bring back 121.6 grams of space rock. That's nearly $10 million per gram of asteroid material. Scale that nightmare to actual mining operations, and we're looking at billions up front with zero guarantee of returns, because the timeline from finding the right asteroid to seeing revenue spans decades. Some estimates push profitability past 2040. And here's the economic paradox that destroys everything: success equals suicide. Tel Aviv University researchers discovered that just one shipment of space minerals could slash gold prices by 50%, successfully flood Earth with platinum from space, and we've just murdered the $660 billion global raw materials economy that made our investment seem profitable in the first place. But even if investors were willing to gamble billions on these economics, they'd face an even more fundamental problem: the legal barrier. Right now, the legal foundation is cracking under pressure. The 1967 Outer Space Treaty explicitly prohibits national appropriation of celestial bodies by any means, but countries are writing their own rules anyway. The USSPACE Act grants companies space resource rights. Even Luxembourg and Japan followed with their own national laws giving mining rights to their companies. Meanwhile, Chinese officials condemn these moves as enclosure of the commons. The result is legal chaos. These national laws are riddled with undefined terms like commercial recovery, creating massive uncertainty for companies trying to operate legally. There's no universally accepted international framework for property rights, liability, or resource distribution, just a regulatory patchwork where conflicts over asteroid claims are inevitable. The gap between theoretical potential and practical implementation isn't just vast, it's systematic. Asteroid mining will remain aspirational until we achieve simultaneous breakthroughs in technology and logistic development, innovative economic models, and collaborative international legal frameworks. But even if we overcome all that, mining could be our undoing. Every ton extracted changes an asteroid's mass, potentially altering its orbit enough to set it on a collision course with Earth decades later. In chasing space riches, we might build our own extinction event.